A breakthrough for scientists after they had a 20-minute conversation with a humpback whale. What if I told you scientists just decoded the language of whales using AI? And it's not what you think. We're not talking about cute noises or random splashes. This discovery might change everything we thought we knew about intelligence on Earth. Whales are responding. Orcas are organizing. And according to some researchers, we may have missed their warnings for years. And she continued to vocalize back to us. Even as she was leaving, it was like, hey, maybe another time we could meet up. Even Tucker Carlson raised eyebrows when this surfaced in scientific circles. The ocean has been speaking. And now, for the first time, we're speaking back. But what the whales might be saying, that's the part no one saw coming. The code beneath the waves. It starts with a click. Not the kind from a keyboard or a camera, but one echoing through the ocean's depths, bouncing off coral walls and drifting through miles of open water. For decades, marine biologists have been listening to these clicks known as coders produced by sperm whales. Massive deep-diving mammals with brains larger than any other on Earth. These clicks weren't random. They were rhythmic, intentional, and repeated with uncanny precision. But the real question was always the same. Were they language or just noise? Scientists had long suspected that these whales were saying more than they let on. Some coders seemed to signal identity like a personal name. Others hinted at emotion or context, such as when pods reunited or calves called out to their mothers. Still, for all the theories, no one could claim to understand the grammar or vocabulary behind the sounds. The technology simply wasn't there. Most analyses relied on human ears, time-consuming spectrograms, and years of guesswork. It was like trying to decipher Morse code in a foreign tongue without a key. But then something changed. In the past few years, the field of marine bioacoustics has collided with another field entirely, artificial intelligence, and the results have been staggering. One of the most ambitious projects leading this charge is called Project Ceti, short for the Cetacean Translation Initiative, based out of the Caribbean. Ceti brings together experts in linguistics, AI, marine biology, robotics, and even cryptography. Their goal is as bold as it is historic, to decode the language of sperm whales and possibly even communicate back. The whales they're studying roam the waters near Dominica, and for good reason. This region is home to stable, multi-generational whale families, meaning researchers can track specific individuals, their social bonds, and their vocal signatures over time. With the help of underwater microphones called hydrophones, and specialized tagging equipment, Ceti has been gathering one of the most extensive databases of sperm whale sounds in the world, over 50,000 hours of recordings and counting. But raw data isn't enough. The real breakthrough came when researchers began applying machine learning models to the recordings. These aren't ordinary algorithms. They're built on the same transformer architecture that powers cutting-edge language models used to process human speech and text. When trained on whale vocalizations, these systems began picking up patterns, layers of structure embedded deep in the clicks. According to researchers, they discovered recurring elements in timing, pitch, rhythm, and spacing that repeat within family pods and even vary between clans. The whales weren't just communicating. They were using what some scientists believe may be the building blocks of a complex language. Some of the early findings include something eerily familiar to humans: dialects. Whales from one region produce slightly different coders than whales from another. And these variations persist across generations. The young spend over a decade learning their family-specific patterns, mimicking them like children learning how to speak. And when males leave to join other pods, they often adapt to the dialect of their new group, shifting their vocalizations to match. That kind of flexibility isn't instinct. It suggests cultural learning. And yet all of this is still the surface. For the scientists on Project Ceti, every data point adds more weight to a single possibility, that sperm whales have been speaking in a structured, meaningful way for millions of years. And we are only now developing the tools to understand them. If true, it wouldn't just change the way we think about whales. It would change how we think about intelligence itself. They've been clicking across oceans long before we built cities or carved letters into stone. The conversation has always been there. The silence was ours. The breakthrough we weren't ready for. For most of modern science, decoding animal communication was a slow, grinding process. A handful of vocalizations, years of behavioral observation, then maybe, just maybe, a hypothesis about what a single sound might mean. For researchers like Jacqueline Orban, who spent years analyzing beluga whale recordings in Canada, the process was frustrating. Hundreds of hours spent listening to one call at a time, looking for patterns by hand. There were no grammar rules, no translation books, no shortcuts, just persistence and patience. But then artificial intelligence entered the equation. When Project SETI introduced machine learning into whale research, it wasn't about automating data processing. It was about uncovering structure in a language no human had ever spoken. The models they used, built on transformer architecture, had already revolutionized human language translation. Now those same systems were being trained on whale coders. What would have taken decades to piece together manually was now being mapped in weeks. Entire lifetimes of audio could be digested, categorized, and compared in a fraction of the time. According to researchers, one of the first surprises came when the AI processed 8,719 sperm whale vocalizations. At first glance, they expected disorganized noise. But the patterns that emerged suggested something far more sophisticated. The whales weren't just repeating sounds. They were building them using consistent components. The AI picked up on 4 core elements that showed up across vocalizations: rhythm, tempo, rubato, and ornamentation. Rhythm referred to the spacing between individual clicks. A coder might have evenly spaced clicks, or it might vary, short bursts or long gaps. According to the team, these differences appeared to map onto message urgency. Faster clicks often showed up in social or reunion contexts. Slower ones appeared during what researchers call deep conversation exchanges. Tempo controlled the speed of the entire sequence. Some communications took just over a second. Others stretched for nearly 5. And those longer sequences weren't random. They followed internal rules that suggested hierarchy and complexity. Rubato, a term borrowed from music, referred to subtle changes in timing that expressed emotion. Just like humans might speak more quickly when they're excited or slow down when serious, whales appear to use tempo shifts to color their speech. Then there was ornamentation, the addition of extra clicks or fluctuations at the end of a pattern. These weren't mistakes. According to researchers, they showed up in very specific contexts, like reunions between mothers and calves. Some scientists believe these may function like emphasis in human language, adding emotional or social weight to a message. When these 4 elements were tracked across different families, the picture became even more intriguing. Each whale group had its own version of common coders. Researchers described them as dialects, variations in rhythm or ornamentation that consistently showed up within certain pods but not others. These weren't accidental. According to the data, young whales spent over a decade learning these dialects from older family members. And it didn't stop there. Some adult males, after migrating to join new pods, adapted their vocalizations to match the new group's style. Scientists were stunned. This kind of vocal flexibility suggests a deep awareness of social context and the ability to change behavior accordingly. In human terms, it's like learning a new accent on purpose to better fit in. Not instinct, adaptation.